We'll now look at some examples of how to use z-scores to determine the area under the normal curve. Again, in order to work these problems, you will need access to the table in your book in section 12.5. Remember that you have a table that shows positive and negative z-scores. Let's begin with an example. IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. Determine the percent of individuals with IQ scores below 115. The first thing that I need to do is take this 115 and I need to convert it to a z-score. Remember that we have a formula to do that. Our formula says that we're going to take the value we're going to subtract off the mean, and we're going to divide by the standard deviation. And so let's plug into this formula. We're going to place 115 in for the value. The problem tells me that the mean is 100. And we know that the standard deviation is 15. So we're going to calculate this. 115 minus 100 on the top is going to give me 15 on the top and 15 on the bottom, which we know equals 1. So what we have found now is that 115, which is a regular data value, is the same thing as a z-score of 1. So the fact that the problem tells me that the scores are normally distributed tells me that these scores will fit on a normal curve. So I'm going to go ahead and draw my normal curve. I know that 0 goes down the middle as the mean. Now, that may be a little confusing because the problem tells us that the mean is 100 and we're placing a mean of 0 down the middle. Just remember that the mean of 100, the 100 is a regular number, it's a data value. The 0 is a z-score. And so those are equivalent if we're told that we have a normal distribution. And the next thing I'm going to do is I'm going to mark off the 115, but remember I need to mark it off as a z-score. So it's a z-score of 1. 1 is positive, so it's going to be on the right side of the curve. And the problem asks me to find the percent of individuals that have scores below 115. So below 115, remember 115 is the 1, below that would indicate that we would need to shade everything to the left. Now, from this point on, we're going to work this problem just as we worked previous problems in this section. We're going to go to our positive z-score table. We're going to look up a z-score of positive 1 and find the corresponding area. So we use the first two digits, the 1.0, down the left-hand side, and the hundredths place digit is also a 0. And so we'll intersect those two, and we see that we've got 0.8413. So let's return to our problem. 0.8413 is the area. And let's remind ourselves that when we look up a z-score in our table, we are finding the area to the left of the number that we looked up, which is perfect because that's exactly what we need here. We need the area from the 1 all the way back to the left, which we know is 8413. Now, the question does ask me to write my answer as a percent, and so remember to convert a decimal to a percent. You're simply going to move that decimal place 2 places to the right, and so our final answer will be 84.13% of the individuals have IQs below 115. Okay, let's move on to the second part of this example. We have exactly the same problem. Mean of 100, standard deviation of 15. We want to determine the percent of individuals with IQ scores between 65 and 120. Now, on this problem, we have 2 calculations to do. We're going to need to convert the 65 to a z-score, and we're also going to need to convert the 120 to a z-score. And we're going to use the same formula that we used in the last part of the example. We're going to say the value, which is going to be the number that we're trying to convert. So 65 in the first one, 120 in the second one. Remember, the formula says value minus the mean. The mean is 100. And we're dividing by the standard deviation of 15. And so we want to calculate both of these. 65 minus 100 is negative 35. And we're going to be dividing that by 15, which is going to give me, and I'm going to round this to 2 decimal places, so negative 2.33. For the bottom one, 120 minus 100 is 20. We're going to divide that by 15. And that's going to give me, again, rounded to 2 decimal places, 1.33. All right, so remember from there we want to draw our normal distribution curve. And we want to mark off both of these values, the negative 2.33, which will be on the left-hand side, and the positive 1.33, which will be on the right-hand side. And the problem asked me to shade in between. And so we'll be shading in between those 2 values. All right, so now we need to go to both of our tables, the negative and the positive one, and look up the areas for these z-scores. So let's go first to the negative table. And we're going to be looking up negative 2.33. All right, so negative 2.3 down the left and a 3 in the 100th place. We'll intersect those 2 and we'll be looking at 0.0099. Okay, and then let's go to the positive table. Let me erase from the last problem. Okay, and so here we're going to be looking up 1.33. So 1.3 down the side, a 3 in the 100th place here as well. And so we have 9082. And so now let's return to our problem. So for negative 2.33, we had an area of 0.0099. So remember again that anything we look up in the table is going to give us the area from that number back to the left. So this area right here, from negative 2.33 back to the left, we found to be 0099. when we looked up the 1.33, and again, that's going to give me the area from the 1.33 all the way back to the left. We found that to be 0.9082. And so how do we find the area of the shaded region? Remember that the 0.0099 is not shaded, which means it's going to need to be subtracted off. So we're going to take 9082, which is the total of these three sections, and we're going to take off the one section that we don't want. So 0.9082 minus 0.0099 leaves me with a final answer of 0.8983, which written as a percent will be 89.83%. Okay, moving on to a new example. Assume the length of time for a horseback ride on a trail is normally distributed with a mean of 3.2 hours and a standard deviation of 0.4 hours. What percent of rides last less than 2.4 hours? Okay, so we want to first convert the 2.4 to a z-score. And by now we should be getting good at this formula. We're going to plug the 2.4 in first, subtract the mean of 3.2, and divide by the standard deviation of 0.4. So on the top, when we subtract those two numbers, we're going to have a negative 0.8. And on the bottom, we have our 0.4. which is going to give me negative 2. And I'm going to go ahead and say negative 2.00 so that we can look it up a little easier in the table in just a minute. And so next up, we draw our curve, and we're going to mark off the 0 down the middle and the negative 2 over on the left-hand side. And we want to know the percent of rides that last less than the 2.4, which is the same thing as the negative 2. So less than that is going to mean that we've shaded in the tail of the curve. Okay, so let's go to our negative table. And what we want to do is we want to look up a z-score of negative 2. So that's going to be negative 2.0 down the side and a 0 in the 100th place. So that's looking like 0.0228. 0.0228. Now again, as you recall, when you look up something in the table, it's going to give you the area from the number that you looked up, which in our case is negative 2, to the left, which is exactly what we need for this problem. So we are done with our answer, except that we do need to write it as a percentage. And so we'll move that decimal place 2 places to the left and write our final answer, 2.28%. All right, so our final example. Assume that the length of time for a horseback ride on a trail is normally distributed with a mean of 3.2 hours and a standard deviation of 0.4. So our same problem, just a different part. What percent of rides last at least 3.7 hours? So we begin by converting the 3.7 to a z-score. So 3.7 goes in for the value. The mean is going to be 3.2, and the standard deviation will be 0.4. So when we do the subtraction on the top, we're going to have 0.5 divided by 0.4, which gives me a z-score of 1.25. So we'll draw our curve. We'll mark off 0 in the middle as always. And 1.25 will be marked off on the right-hand side because it's positive. We want to go at least that. Remember that at least means that or more. And so we're going to shade to the right. All right, so let's go to our positive table. And we want to look up 1.25. So 1.2 down the side, the 5 across the top, and it looks like we will be at 89.44. And so we'll return to our problem, remembering 89.44. And again, remember that 89.44 is the area from the number that we looked up, which was 1.25, back to the left. And so since it is not a shaded region, we know that it will have to be subtracted off. We will subtract off from the whole curve, which is 1. We'll take off the 89.44, which should leave me the area of the shaded region at 0.1056. And again, writing this as a percentage, our final answer will be 10.56%.